My name is Keith Rucker. So today we've got the shaft out here that we turned in a previous video to get ready for the pulleys to go on. Again, this is a 2-inch shaft, but we need to get it down to 1 15/16. So we turned both ends on the lathe. If you want to see how we did that, keeping everything concentric with one another, you can go back and look at one of my previous videos that details that. But the job for the day is we need to get this shaft onto the machine, and we need to go ahead and pour the Babbitt bearings. So this is an old machine, pre-ball bearings, early 1900s, and back then they used a material called Babbitt for bearing surfaces, and basically it's a soft metal that has some tin, it has some lead, it has some other, it's an alloy basically, and it just creates a soft pad that allows that shaft to turn, and you keep it oiled, and the shaft is basically turning on a layer of oil. But by having that softer material under it, it won't damage the shaft, at least in theory, while it's turning if it gets a little bit hot or whatever. So, and they actually make very good bearings. They were used for many years. In fact, they're still being used in some applications today. Babbitt is. But the task for the day again is to go ahead and get these poured, and we will actually pour the bearings around the shaft. We will use this shaft as a mold to pour the bearings around. And then we will come in there and scrape them out and get everything running real nice and true. So the shaft is ready to go. What I'm going to do next is we're going to make some little collars on the lathe that will fit up over the shaft real nice and tight, and it will just barely ride in the edge of this bearing shell down here, and that will just be to position the shaft to get it aligned properly. Once we get those made, we'll be able to go ahead and start the Babbitt pour. So let's get over on the lathe, and we'll start turning those little collars and get this project on the road. This is just a little drawing of what I'm going to try to make. So I've got some 2 5/8 inch diameter stock that I'm going to turn this out of. I'm not even going to worry about turning the outside. It's really irrelevant. The only thing that I'm really worried about is getting this outside diameter here, which needs to be about 2 1/4 inches, 2.250 inches. And even that measurement isn't super critical. The big one is the diameter, so we need to bore this out so this collar can slide up on that shaft, and of course that needs to be 1 15/16. So anyway, this is what we're after, and we'll show you over here on the lathe and go ahead and get started on this. Now you can see how we're using these bushings. We've got the shaft going through the bearing and the bottom bearing block down there, and basically that little lip that we cut on there sits on the edge of that bearing block, and its main purpose is just to locate the shaft in that bearing shell. So now it's basically centered up in the center, and that's going to support the shaft and keep it aligned while we pour the Babbitt. And it also conveniently serves as a dam on the end of the shaft to keep the Babbitt from pouring out of the end when it's in its molten state. So anyway, we've got one of these now on both sides of the machine, and the machine is pretty much in place. Here we are looking down on the inside of the machine, and in here there's actually 2 collars, and those collars you probably saw in the last video, but those are in there, and basically the purpose of these collars, those will be permanently mounted on the shaft, and that basically serves as a thrust bearing on either side, so it prevents that shaft from moving laterally either left or right in there. And again, conveniently for pouring the Babbitt, they will serve as a dam on the end of the shaft to keep the Babbitt from pouring out. And we'll add some damming material around that just to make sure it doesn't leak. But that will give us a nice finish on the end of those bearings for the Babbitt. And on the other side of the machine, same thing. We have the spacer, the bushing that we turned, and again, it will index it, keep it centered up on that bearing shaft, and will help us in the pour. So we got our jig pretty much ready to go. So now we're going to get this shaft ready to pour. We're going to smoke the shaft, and then we'll put some Babbitt right around the ends to help dam up those ends. Alright, so now the next step we're going to do in this is we're going to smoke the shaft. We're going to coat it with a layer of carbon, and that's just to kind of give a little release agent between the Babbitt and the metal here for when we get ready to take this back apart and get the shaft out, so that we don't get the Babbitt actually sticking to it. So to do that, we're just going to use the oxyacetylene torch, and we'll light it up, and I'm going to turn the flame all the way back until it's just making a lot of smoke, and we'll just go back and forth on the shaft, coating it with a layer of carbon. Alright, that looks good. We'll do the other side as well. Next step here is we want to make sure we got this dammed up real good all the way around this, and we're not having any leaks of the molten metal coming out around the shaft. And to do that, what we're going to use is a material called Babbitt Right, and this is a damming material. It's it's basically just kind of the consistency of about Play-Doh, and you can mold it in your hands, do some things with it like this. And we're just going to take this material and put it around the edge of this piece where the metal may come out. So we've got this collar that we made right up there flush against it, but still there's some little cracks all the way around it, as well as on the inside here, that the metal can come out. So we're just going to take this material and just kind of mold it around there, and this will just form an extra layer of damming to make sure that that molten metal stays inside the shaft. And we'll do this on all the way around on both sides, on both shafts. And now basically the area in here that we're wanting to pour the metal, it's all contained, and there should not be any place for that molten metal to escape other than out the top here where we're going to do the pour through. So we'll go ahead and get this around all the shafts, all four places it may come out, and be back with you in a minute. All right, here you see on the inside of the shaft, we got the Babbitt Right around here as well, and it's on both sides of the bushing, and it's unlikely that it would pass through the bushing around that shaft. It's a pretty tight fit, but I've just learned that it's easier to go ahead and dam anything up that the Babbitt may come around than to have a leak in the middle of a pour and have to deal with it then. So better safe than sorry. So we've got, again, both sides here dammed up, and again on the outside dammed up. So everything's ready now to start applying some heat, and we'll do the pour here in just a little bit. So here we are, we're melting the Babbitt in a ladle, and I'm just using a little propane camp stove as a heat source, and this has been sitting on here for a little while, and it's starting to bubble a little bit and melt down. It takes probably 15-20 minutes for this stuff to get heated up to the right temperature. So we're just going to let this cook, and while that's working on heating up, we'll come over here and start putting some heat in the shaft and the bearing block as well. So now we're going to work on getting some heat in all these shafting and the bearing block. This is just kind of preheating it a little bit. And again, the goal here is not to get this thing red hot, not to get it, it's just to get it a couple of 100 degrees so that you don't have that quite so much of a cooling the second the hot Babbitt touches this metal. What we want to do is we want to have it where it's going to be, you know, fairly close to the right temperature. So Babbitt is going to melt somewhere around between 600 and 800 degrees, depending on the type of Babbitt that you have. So, you know, I would like to get these everything in here up to about 300, 350 degrees for the pour, and that's going to make it go a lot easier. So anyway, we'll just concentrate some heat in here and try to get all this preheated. So we've got the top bearing cap on now, and just kind of let you know what we did. After everything cooled off, we took it apart, took the shaft out, actually took the bottom bearing blocks off. I did this off camera. You know, if you guys are really interested in seeing this Babbitt bearing demo, I've got another video that really goes into a lot more detail that you can go back in my archives and look at. But just briefly telling you what we did. Like I said, we took them out, we cleaned them up, got all the Babbitt off the top, filed it down flush, took a scraper, kind of cleaned it out real good, put it back on, and then in between these, the top and the bottom, we cut some spacers that go in there. I just used some gasket paper, and then we clamped the top bearing cap here back on with the bolts, got it good and tight, and then again packed everything up with the damming material. And I've actually already started putting a little bit of heat on these, and we got the Babbitt melting over there. I'm gonna put just a little bit more heat on them, and we should be ready to pour this side. Okay, that's it. I let these bearings sit on the machine overnight and cool off, and it's now the next day. I've come in, I've pulled the caps off, and what you're looking at here is the bottom side of the top cap on one of the sides. I got the other one over here behind me. But there is still some work that we need to do to finish these out. And you can see I got a pretty nice pour in here. There are a few irregularities in here, which is normal, particularly on the top cap, just because you can't really get that shaft preheated as well in this one, and you get some cooling as you're pouring it in there. But we're not really shooting for an absolute perfect surface with Babbitt. Really, about if you get 75–80% contact, you're doing good. And we're actually going to come in here and scratch some oil grooves in here for the oil to be able to flow. So a lot of times when you have like a little bubble or a dimple in here, it's not a big deal. Don't worry about it. That's just a place for the oil to collect to help keep that shaft lubricated. So you know, don't fret too much over this. We're actually going to be able to smooth this up a good bit with some scraping. Right now, the first thing I'm going to do is just kind of knock all this down flush. You know, I had some places where the Babbitt kind of seeped in around my spacers that I put in here, and we want to get all that flush. And I'm just going to use a file, and I've got here basically it's a horseshoer's rasp, and I'm not using the real coarse side, but still this is pretty coarse. And Babbitt is a very soft material, so it will file with this very easily. And you can just surface this down to flush with the bearing shell very quickly with a file like this. Alright, we got you zoomed in now kind of close so you can really see what's going on. And now I'm just going to do a light scraping, and to do that I'm going to use some of these little Babbitt scrapers that I have here. You know, these are just on a handle. And first thing I like to do is I like to just kind of cut this corner down across here. Make sure I don't have any sharp edges on there. And again, Babbitt's pretty soft, so you can shape it pretty easily with one of these tools. And now what I'm going to do is just taking this tool, come in here on the bottom, and we're going to do we're not really scraping it to fit, but I do like to just kind of knock off any rough edges in here. And get a good surface to work with. And I have different kinds of scrapers. For example, this triangular scraper here. This one is real good because you can get a nice, fairly good scrape across the entire surface. And when you're dealing with a round shaft, you know, this is a nice one to get in here with. And, you know, make sure you're not starting by getting one area lower than the other. And the whole concept of scraping is to knock off the highs and get a good fit where you're getting good contact. Now, I probably won't go through the whole process of doing this on camera because it's very time consuming. It takes a long time. But we'll go through a series of putting these onto the shaft and using some bluing in here and seeing where the high spots are, scraping it off, and getting a good fit. So we're bluing up, again, 75–80% of the surface area in here. But for right now, again, we're just trying to get it ready to go back onto the machine and just get these cleaned up. So, you know, for right now, I'm probably not going to do much more scraping than that right there. I'm just making sure that I don't have any high spots in here, any rough areas that I'm cutting out. So now we're going to go over here and punch the oil holes through on the drill press, and then we're going to carve in an oil groove. All right, as you see, we've got the holes in there now. I just punched a 3/8 inch hole through the same pour hole we had on the other side. And there was 2 holes in here originally. One on each side. One of them served as a vent during the pouring, which turned out real nice. But I've got 2 oil holes in here. And the first thing I'm going to do is this is a chisel that I made. It's actually made out of a punch. And it's just got a little triangular kind of a point on the end. And I'm just going to use this to kind of V me out a little groove that goes between these two holes. I want to connect them together. And I'll just start by scratching them in there, and then I'm going to take a little hammer and just gently tap these out. Alright, that's a good start. We'll clean this up and get it uniform across. Alright, so now I'm going to also continue these on out almost to the end, so, you know, about half that distance in this case. This little channel is just going to be a channel to kind of go from those pour holes all the way across the top of the bearing, and make sure that you've got oil coming in contact with the shaft from one side to the other. Now I'm going to come in from the ends, and we're just going to scratch a little V shape. groove to connect to the main ones here. And again, this is just to kind of help to get oil out to the edges. And we'll do the same thing over here. Alright, I'm going to cut some more oil hole grooves here, and I'll show you the finished process in a minute. Hopefully you can see the oil grooves in here that I've kind of carved into this Babbitt. And again, that's just going to give a little channel for the oil to get in there and totally lubricate the top of that bearing, which should do a good job for us. And this one is ready to go back on. I'm going to spend a little bit of time getting the other top cap ready to go back on. We'll put them back on the machine, put some oil in there, or actually I'll start the scraping process. And again, I'm not going to show all of that on video, but at the end we should have a nice turning shaft. And very often after you pour Babbitt and you run the machine in for a little while, it's necessary to go back in there and kind of look at your shafts and take these caps off, make sure you got good, you're not getting any wear in certain areas, and maybe do a little final scraping after you've ran it a couple hours, and also feeling of the caps and make sure they're not getting too hot. But this looks like a good pour. I'm very happy with the results so far, and we'll see what we end up with after we do some more scraping. Well guys, we got the bearings all finished up now, and again I apologize for not taking the time to really go through the scraping process. It's a tedious process, and I went through these things, taking them on and off about 4 or 5 times, and anyway, I've done it in other videos, and it's just time crunch. Didn't really just want to take the time to do it today. But I did go through that process, and we went ahead and got the pulleys that we'd shown you before. These were all cleaned up, sandblasted, and put back on. They're now installed, and we got a nice turning shaft. You know, it's probably going to take a little bit of adjustment on the bearings as the machine wears in, but right now, you know, it's turning pretty good. So I'm pretty happy with everything, the way it's worked out, and this part's done, and we're ready to move on to the next step on this project. So again, you know, we're getting kind of into the short rows on finishing this thing up after nearly 2 years. Let's see, we've got the outfeed table on. I'll show a picture of that for you guys to see. You know, we got that cleaned up and on this weekend. We got the shaft and bearings and the wheels all turned and put on here this week. Really, the main things that's left on this is I think we're ready to go ahead and put the table on here. I've been waiting to do that until I get everything down here finished up, because once I put it on, it just makes it difficult for me to get access to it. But I think I've got all that pretty much done. So we'll probably sandblast that, get that back installed, and then the final will be the counter shaft, or the jack shaft on this machine, which will mount down here. There'll be 2 bearing blocks there, plus a outboard bearing over here, and I think there's 5 pulleys that will mount on that shaft, if I remember right, that will basically drive everything on the machine. Still need to find a piece of 1 15/16 shafting for that. Quite honestly, I haven't done a lot of looking on that yet. I've been concentrating on getting this, but I'm going to be trying to source out a piece. I need about an 8-foot long piece for that, and I got some 2-inch stock, but I really don't want to have to turn it down. It's just going to be too much of a job. So and it pretty much needs to be that diameter, the entire length, and with putting pulleys on there, it needs to be pretty exact. So I'm going to try to find me a piece of 1 15/16 8-foot long shaft for that, and that's going to take a little while. I mean, we got 3 bearings to do and get all the pulleys cleaned up and put on there, but again, I'm very pleased with the progress on this. I'm hoping it won't be too much longer, and we'll be able to start putting some belts on here and at least firing it up. Again, probably without any knives at first. I want to just kind of run it in, and then once we're comfortable everything's working like it should, then we'll go ahead and start putting knives on here and be able to start planing some lumber. So exciting. So thank you guys for watching. I will just make one quick comment. I know I had said in my video last week I was going to try to pour some brass this week, and this past week, well, let's just say that life got in the way, and I didn't get home hardly a single night this past week before 9 p.m. Between some things that came up at work and some things going on at the house. Nothing major, just life got in the way. So that didn't happen this past week. I decided this weekend I really wanted to get this finished up. This was a priority for me, so we came out and jumped on this. Now that this is done, my next thing is to do the brass pour. And if life doesn't get in the way this week, maybe one night this week, I'll get out and get that done, because I know you guys are looking forward to seeing that, and I'm looking forward to getting it done. So hopefully we'll do that this week. So that's about all for this episode, I think. And again, I appreciate everybody for watching. If you haven't already, please subscribe to my channel. And thank you for all your comments you guys send in. As always, I enjoy reading them and hearing from you guys. So thank you very much. We'll catch you next time.